Just following on the previous video on the theory part of the list, I have now two questions from the past papers to clarify the theory part. Okay, ship of displacement 20,000 ton, km 7.6 meter, kg 6.2 meter, FSM 1200 ton meter, TPC 30 ton. The ship is listed 3 degrees to starboard. So in this question, you can see the first line says that the ship is already listed 3 degrees to starboard. Ship is not upright, so there is already a listing moment, because if the ship is listed to starboard, there is already a listing moment which is causing the ship to list to starboard, which must be considered. Present mean draft is 8.4 meter and she has to finish loading at 8.6 mean draft. Okay, present draft is 8.4. The loading will complete at 8.6 meter mean draft. Space is available 6 meters on port side and 5 meters on starboard side of the center line. State how much cargo to be stored on either side to finish upright. Okay. So the ship is already listed to starboard. There is an initial listing moment which we must first consider. What is that moment which is already listing the ship to starboard? You know the formula tan theta is Gg1 upon Gm fluid. So this is now focusing on the initial condition, not the final condition. We have not started loading because my initial condition itself vessel is listed. So I need to find out what is the initial listing moment. So tan theta, that is the initial list, is the initial Gg1 upon Gm fluid. Now, you know what is Gg1? Gg1 is the listing moment upon displacement, W. So ILM is initial listing moment divided by displacement, W, gives the Gg1 upon Gm fluid. So theta is 3 degrees. In initial list is 3 degrees to starboard. So tan of 3 degrees multiplied by displacement W multiplied by Gm fluid gives me the initial listing moment, okay, from this formula. So I just cross multiply tan theta into W into Gm fluid gives me the initial listing moment, which is to starboard. So I know theta, which is 3 degrees given in the question. Displacement, initial displacement is 20,000, and Gm fluid will be FSM upon, first we have to find the Gm fluid, okay. So what is free surface correction? FSM upon W, displacement. FSM is 1200 tons and displacement is 20,000. So FSM upon displacement 1200 upon 20,000 gives 0.06 meter is the FSC. Km is given in the question 7.6, kg is 6.2, Gm solid will be Km minus kg 1.40 meter, FSC which I just found here 0.06, I will subtract 0.06 from Gm solid, I get the Gm fluid initial 1.34. Okay, so Gm fluid in the initial condition is 1.34, which is now inserted here in this formula. Tan of 3 degrees multiplied by displacement into Gm fluid, initial Gm fluid, because that is being equated to initial listing moment, which is to starboard. Okay, put the value of tan of 3 degrees and multiply all the three figures. You get 1404.53 ton meter, which is the initial listing moment towards starboard side, because ship is listed 3 degrees to starboard. Okay, now we want to know how much cargo we're going to load. What will be the mean sinkage? Final sailing draft is 8.6 meter. Present draft is 8.4 meter, mean draft. Difference of the two is 20 centimeters. Now cargo to load will be mean sinkage into TPC. TPC given in the question is 20 tons. So, 30 tons. 30 tons is the TPC and sinkage will be 20 centimeter. So sinkage into TPC gives me 600 ton. Total cargo to load is 600 ton. Now we have to distribute this cargo in such a manner on the port side and starboard side that the ship will end up upright condition. What is upright condition? All the listing moments to port are equal to listing moments to starboard. The ship will be upright. There should not be any net listing moment. The listing moment to port should be equal to listing moments to starboard. The ship will be upright. And what is listing moment? Weight multiplied by distance from the center line. So to finish in upright condition, listing moment to port must be equal to listing moment to starboard. Okay. So let cargo to load on the port side be x tons. Then cargo to load on starboard side will be 600 minus x, totally 600. So x ton I am loading on the port side, 600 minus x I will load on the starboard side. So the x ton which I am loading on the port side will be 6 meters from the center line. So it will cause a listing moment by 6 into x. That will go to the port side. Now starboard side, I already have an initial listing moment to starboard. ILM to starboard already have, plus the cargo which I am going to load on starboard side will add to it, the listing moment. So what is the cargo on starboard side? 600 minus x, and the starboard side space where I am loading cargo is 5 meters from the center line. Okay, is it given here in the question? 6 meter space is available, 6 meter on port side and 5 meter on starboard side of the center line. Okay, so this was the main thing here to understand that listing moment to port is the cargo, weight of the cargo x ton multiplied by distance from center line 6x. Listing moment to starboard will be by the cargo will be 600 minus x, remaining cargo, multiplied by its distance 5 meter from center line, plus because the ship is already listed to starboard, there is an initial listing moment which we have found out, that will be added to the listing moment to starboard side. So 1404.53 is the initial listing moment to starboard plus the listing moment caused by the cargo. So only x is the only variable. You can solve the x and you get the answer 400.4 tons on the port side. 600 minus 400.4 will be 199.6 ton on the starboard side. So this is the answer. Now the second question, I hope this is quite clear. You can do it yourself, rewatch it. The second question is on derrick. A ship displacing 8,500 ton, GM is 1 meter. So initial GM is given 1 meter. This ship is listed 2.5 degree on the port side. A weight of 60 ton on deck, kg of the weight is 11.5 meter and it is 3.5 meter on the port side of the center line. So this weight of 60 ton on deck, kg 11.5 meter and 3.5 meter to the port of center line is to be discharged over the starboard side. Okay, so ship is starboard side alongside, weight is on the port side. We have to pick up the weight and then swing the derrick and discharge it on the starboard side. Using her derrick, the head of which is 21 meters above the keel. The head of the derrick is 21 meters above the keel and outreach is 10 meters from the center line. So when the derrick is swung over on the starboard side, the cargo will be 10 meters from the center line, which is the outreach of the derrick is 10 meters from the center line. So the hook of the derrick where the cargo is suspended, that will be 10 meters from the center line on the starboard side. So calculate the list when the weight is just picked up by the derrick plumbed over the weight. Derrick is plumbed over the weight and it is just picked up. So sometimes some people will confuse that, oh, how can there be any list? Because I have only just picked up the weight. Weight is still where it was on the port side. No, you remember that tan theta, the list formula is GG1 upon GM fluid. GM will change, so theta will change because as soon as the weight is picked up, the kg of the weight, center of gravity of the weight will shoot up to the head of the derrick. You can see this diagram here. Okay, this is the derrick. This is the derrick and weight W is there, 3.5 meters port side of the center line. Kg of the weight is given 11.5 meter. Head of the derrick, which is plumbed over the, when it is plumbed over the weight for picking up, the head of the derrick that time is 21 meter from the keel. So as soon as the weight is picked up, the center of gravity of the weight will shoot up to the head of the derrick, means kg of the weight was 11.5 will become 21. So 21 minus 11.5 is 9.5 meter will be, the effect will be as if you have shifted the weight vertically upwards by a distance of 9.5 meter. So we will calculate the final kg because of this shift, and then we will get the new GM fluid that will give us the tan theta. GG1 in this case, the ship's center of gravity is not going to change because weight is still 3.5 meter on the port side. So GG1 will not change, only GM fluid will change in the first part. So let's see. Now this is the initial diagram, initial condition. Ship is listed 2.5 degree to the port side. The angle theta is 2.5 degree. And this is the initial GG1 upon GM. So initial GG1 upon GM gives me GG1 initially, the ship's center of gravity, how much it has shifted to the port side on the transversely will be equal to GM into tan theta. GM is given, there is no free surface given in the question anywhere. They say 2.5 degree weight, so there is no free surface given. So no problem with the FSC here. Otherwise, we have to apply. GM, initial GM is 1 meter. Initially, the ship is listed 2.5 degree. So tan is 2.5 degree and GG1 0.04366 meter. This is the initial. Initially, the ship's center of gravity is 0.04366, this many meters off from the center line on the port side. Now initial kg of the weight 11.5 meter. After lifting by derrick, kg will become 21 meter. It will shoot to the derrick head. Shift of center of gravity of the weight will be 21 minus 11.5. 9.5 meter is like the weight has shifted 9.5 meter vertically upwards. So what will be the vertical shift in the ship's center of gravity? Now this GG1, this GG1 is not transverse. I have put the arrow vertically upward. So this is the ship's kg shifting vertically upward from G to G1. So how much will be the shift in the ship's kg? Weight W multiplied by distance by which weight has shifted upon displacement. 60 tons is the weight. We found the distance by which it has shifted vertically upwards is center of gravity 9.5, initial displacement 8500. So 0.067 meter is the vertical shift upward of the ship's center of gravity. Means the kg of the ship will increase by 0.067. So in other words, this will be the reduction in the GM. If the ship's kg is shifting upward by 0.067, that is the reduction in the GM. So original GM was 1 meter, reduction in the GM is 0.067 meter, final GM is 0.933 meter. So this is what has happened to the GM. So as soon as the weight is just lifted, the ship's GM reduces from 1 meter to 0.933 meter. So now I can apply the formula tan theta is Gg1 upon Gm. So this Gg1, it has got a bar on top. This is a transverse Gg1. So it's not the vertical Gg1, it is a transverse Gg1. Transverse Gg1, which we have found here. Here, Gg1 is equal to Gm tan theta. Gm, initial Gm 1 meter, initial list 2.5 degree. So transverse Gg1 0.04366. So that Gg1 will remain. The ship's center of gravity is with of the center line. That is not changing because only the Gm is changing and the list is changing. So tan theta with Gg1 upon Gm, you divide 0.0436 with new GM found 0.933 and the theta will comes out to be 2.68 degree to the port. It was 2.5 degree. It was 2.5 degree to the port and cargo is still 3.5 meter off the center line. But just by lifting by the derrick, the list has increased from 2.5 to 2.68 degree to the port. Simply because the GM has become less. Now the second part is when now the derrick has been swung out to the starboard side. The weight has been picked up. The derrick head remains same 21 meter above the keel and it is just been swung on the starboard side. So it is swung on the starboard side. The cargo is now 10 meters from the center line. The outreach of the derrick from center line is 10 meter. So cargo is now 10 meter from the center line. Cargo was 3.5 meter on the port side. It has now shifted 10 meter on the starboard side. So total shift will be how much? 3.5 plus 10. 13.5 meter is the shift of the cargo. So now our transverse shift of ship center of gravity Gg1 will change because the cargo has been now transversely, there has been a transverse movement of the cargo. The ship's displacement W into transverse Gg1 is the listing moment, which I told you in the theory part. This is the main formula. And also we know that Gg1 upon Gm is tan theta. So Gg1 is equal to Gm tan theta. Initial listing moment will be W into Gm tan theta. So I put the value of Gg1 from here. GG1 is GM tan theta. I insert here. It becomes W with shift displacement into GM tan theta. So this is the initial listing moment W into GM tan theta, which is 8,500 into 1 into initial list 2.5. 371.118 is the initial listing moment when the cargo was just picked up before swinging. Before swinging the derrick, the I'm sorry, not before cargo picking up. Before picking up the cargo, initial condition of the vessel. Vessel was 2.5 degree listed to the port. Cargo is still not picked up. That time the listing moment was W into GM into tan theta. Original GM 1 meter, original list 2.5 and original displacement. All initial conditions. So there was a listing moment 371.118 to the port before we did the operation. Now the derrick has been swung overboard to starboard. Shift of the cargo from center line 3.5 plus 10, as I explained. It was 3.5 on the port side, now it's 10 on the starboard side. Total 13.5 meter cargo has shifted. What is the listing moment cause? Weight of the cargo multiplied by distance by which it has shifted. 60 ton cargo, distance by which shifted 13.5, 810 ton meter is the listing moment to the starboard caused by the cargo. So initial listing moment was to the port 371.118 and resultant listing moment to starboard will be 810 minus 371.118. So cargo has caused the listing moment caused by the cargo is more than the initial listing moment. Initial listing moment was 371.118. Cargo has caused listing moment 810, which is bigger than this to the starboard. So the ship will finally list to starboard. Net listing moment will be starboard listing moment 810 minus port listing moment will be the resultant or final listing moment to starboard. So the ship's center of gravity will now shift from G to G1. How much will that be? The displacement into GG1 will be now 438.882. Okay, the listing moment is always the final where the shift center of gravity has shifted to the starboard side GG1 final into the displacement. Cargo has not been discharged, so W remains the same. So the listing moment caused will be equal to W into new GG1. GG1 will be 438.882 upon displacement. Cargo is still not discharged. It has just been swung. And the question is not saying cargo discharged. It is just swung. So the displacement is still the same, 8500. This is the GG1. And tan theta is GG1 upon GM. GM is the final GM after picking up the cargo. When we've lifted up the cargo, it has reduced from 1 meter to 0.933 because now this is final condition. So everything will be final. And we get 3.16 degrees starboard list. Okay, you can watch it again, and if there are any comments, you can leave the comment. This is a typical examination, past examination paper question. So the first, how much the list changed as soon as the cargo is picked up because GM reduced. That is why the list changed, even though the cargo was still 3.5 meter on the port side original. So the ship's center of gravity is going to move only if the some weight is weight distance of the weight from the port side or starboard side of the center line is changed. So in the initial condition, the GG1 did not change. But when the cargo was swung to the starboard side, yes, then the ship's center of gravity shifted to the starboard side. So net listing moment will be always equal to the final GG1 into displacement. Okay, you can go through this again, and if there are any comments, you can leave them and clear the understanding. Thank you very much.